Hi, I'm Mike Bush.
I'm Paul New.
And I'm Colleen Sterling. Welcome to Ask the A&Ps from AOPA.
Ask the A&P is the show where you ask your toughest maintenance questions, and we do our very best to try to answer them. Sometimes we even succeed. So if you have a tough question, please email it to us at podcasts@aopa.org for a chance to get on the show.
And always remember to click and subscribe so you never miss a wrong answer or a right answer or whatever we come up with.
And if you'd like to get on our email list for our monthly newsletter and other good stuff, the easiest way to do that is to text the word savvy, SAVVY, to 33777. And your phone will ask you for your name and email address and add you to our mailing list. Again, text savvy, SAVVY, to 33777 to put yourself on our list.
So, Paul.
Yes.
Where?
For the people that can see on YouTube, where are you?
Well, so
the floor is much too shiny for you to be in your shop.
I could eat off that
in
floor.
Tennessee.
No, yeah. It is not my shop.
And that airplane behind you does not look like the kind you usually work on.
No, this is really cool. So I happen to be away from home doing a pre-buy on a TTX. And it so happens that the seller of the airplane happens to live in these two phenomenal hangars with tile floors and a PT-13.
Yeah.
So you both know, in a minute, you'll know where I am. So I am at the birthplace is not the right word, but when the bore scoping of valves became a really big deal, it started here.
There's a birthplace of valve.
Sort of, kind of. So here's another hint. I'm going to move the camera.
That's because Adrian's there.
You recognize that airplane?
Oh yeah, that's a beautiful Bonanza.
You'll notice the tip tanks.
Oh, with the tip tanks, yeah.
Yeah.
Had to go far.
100 gallons per tip tank.
Big Berthas. That's Adrian's airplane.
Yeah. Let's see, the Mae West or the Dolly Partons, whatever.
He got FAA approval for those, and then he was assured that the FAA would never make that mistake again, and there will never be another Bonanza approved with those tips.
Yeah.
Wow.
So we were over yesterday. We were looking at the bird dog that he has that he's starting to restore, which is just amazing.
Nice.
It's in like 1,000 pieces at the moment. And in a couple of years, it'll look, brand new. He has to be careful because Adrian is the guy that, when you open the cowling on his Bonanza, all the screws on the hose clamps, the slots on the screws are lined up. And so
I remember talking with him. It's true.
Yeah, it's just crazy. So, but this bird dog that he has, he's trying to make it like original, which means it's going to be way nicer than it ever was when it came from the factory once he gets done with it, because he won't be able to not make it that nice. But anyway, he showed me all the original borescope equipment that he has, which he hasn't used in forever because it's now so antiquated.
Yeah.
And I did a borescope on this TTX this morning using my portable $200 scope that travels with me, and it's just amazing. But anyway, so yeah, this is cool. We've had a lot of fun. And
you ever have problems with TSA with that scope when you're flying someplace?
Well, no, it's interesting. I've even flown with a magneto. I've gone to Australia and done the CPPs with the Cirrus group, the COPA group, and I carry a magneto so I can demonstrate impulse couplings, and it goes right through. They've never batted an eye. It's kind of bizarre.
So you put it in checked luggage, right? You don't.
I do put it in checked luggage.
That's
but even
the
borescope in carry-on, I have a special one, not a special one, but I have one of the flexibles. So it can fit in a smaller container in my backpack.
Mm-hmm.
The straight ones are too long, and everybody thinks you're going around
Right.
with a pool cue.
Yeah.
But I have taken those before, and then they
You know,
go
when the-
through okay.
When TSA asks you about it, you just tell them you're a proctologist, and they leave you alone.
They run away.
Yeah, I did have a lady in Memphis ask me what the magneto was,
Uh-huh.
and I told her it's a magneto, and she looked at me kind of funny. I said it's an airplane part. She goes,
Mhm.
"Oh, okay," and that was it.
Wow.
I was real surprised that they weren't more interested. Oh well, I should have told her it was a defibrillator.
Yeah.
It'll stop it and start it, depending on what you need.
So our first question is from John, who is trying to straighten up and ply right.
Oh gosh.
I didn't write that, John.
Yeah.
Go ahead, John. What's your question?
I couldn't have said it better. So I recently took over as the maintenance officer for a small flying club. We have thankfully just a single Piper Cherokee, about as simple as it gets.
Mhm.
I looked at the manual and it called for 4-ply tires. However, I've found that historically our previous maintenance officer and even A&Ps on the field have installed 6-ply tires on both our aircraft and, well, many others around the field who will remain nameless. I decided to go looking just to see what had happened out there. And it got me thinking, maybe I've been missing something, or maybe this is just where some deviation has been normalized. But also I recognize that tires have come a long way in 60 years. And I've heard some things about ply ratings versus actual, ply as in multiple layers in the tires. So I was hoping that you might demystify
Now we're getting
some
extreme
of
here.
yeah, exactly. But just help me understand, was it okay that they were putting 6-ply on there when supply dictated that was what was available on the shelf, or are we being very naughty? Is everyone else on the field being very naughty?
Well, I'm being naughty because I'm putting 6-plies on my airplane. So I'm in the same boat. And I think it's because I haven't been able to get the 4-plies.
Yeah, I'm in the same boat. I've had to replace a couple of tires on my 310 for reasons that I don't want to discuss, and the ply rating for those 10.5-inch tires that are the main tires of the 310 are just simply not available, and I had to go up to the next higher ply rating to get them.
And you're a retractable like me. And so there is a concern that the 6-ply tire fits in the wheel wells. So you're supposed to do a retraction test to make sure it's okay. And it's always been okay for me. Or am I confusing retreads, Mike? I
don't think that there's a dimensional issue
difference?
with those.
Are they heavier?
Because the tires all have to comply with a TSO that states their maximum dimensions.
What about weight? Is the weight different with a 6-ply?
That's an interesting question.
I mean, it's not.
Have you ever
weighed a
specified.
tire?
Yeah, is weight stamped on a tire? Or something? I mean, there's all sorts of stuff stamped on a tire.
Well,
I
now
don't
wait a
think
minute. Would
so.
that be inflated weight? How far are we
At
going to go?
any rate, we're all guilty of applying our tires. So
Applying, yeah.
it may be that when this podcast goes live, we all get arrested by the FAA and hauled off to FAA prison. I don't know.
The tire ply is not specified on the type certificate, so it's not a deviation from what a certificated airplane is supposed to have, but it might be specified in the service manual.
It's in the parts manual.
It's in the parts catalog, which is not an approved document.
Okay.
I describe it kind of as a glorified sales brochure.
It's an acceptable document.
It's an acceptable document for sure.
Okay.
And we have the 210 that I do a lot of work on is kind of an odd bird. It's not an odd bird, but the older airplanes would have 6-ply main tires. The newer ones would have 8-ply main tires. And it's real common that we find the opposite has been done, where someone will put a 6-ply on an airplane that requires an 8-ply.
Oh.
The
That's,
Piper
that's
Saratoga.
probably not good.
No, that's not good. So my general rule of thumb is I don't ever mind the ply being increased by 1, but never decreased. And retreads, a lot of folks think retreads are a bad idea, but if it's a standard retread, it has to meet the exact same dimensions as the original tire.
Right.
We did have, so now Desser has the monster retreads. And if you don't have wheel fairings and you're not a retractable gear airplane, you can probably install the monster retreads. I had a 152 years ago that I rented out, and I put monster retreads on it because the airplane flew like,
And they'll last absolutely forever.
Yeah, this airplane flew 500 hours a year, and it was all in the pattern, And man, those tires would last forever. But I also had a customer bring his 210 to us. This has been 3 years ago. And he said, I just put some brand new tires on, so you won't need to do that. I'm like, okay, we put it on jacks and didn't think much of it until we retracted it. And this is a 210 that did not have gear doors. And the tires caught the skins as they went inside the wheel well.
Whoa.
And it was bending a little bit. And then, it popped past it. I'm like, wait,
Ooh.
that's not right. What happened here? So we put the gear down and they almost didn't come down. Finally the hydraulic pressure pulled it out. And that's when it, it's like you stare at something and you don't see it.
This tire is too big.
This tire. And then I got to look at it. I was like, holy smokes, those are massive.
Wow. Wow.
He was
good
not
catch.
happy.
Yeah.
So
Well,
we took them off. He brought us some different tires and he gave the big tires to a 182 friend that lived in the T hangar next to him.
uh-huh. Wow. Yeah. So,
But John, that was a long way around
to
to say,
John.
yeah. Oh yeah, John's here. Hey, John.
yeah.
Hey.
Sorry.
So the bottom line is we're all guilty as charged. So
Yeah.
you're in good company.
We can't think of a reason
Yeah.
not to do it.
Yeah, we think it's fine.
Great. Thank you so much.
Now
I appreciate it.
the ply rating, I think that the manufacturer assigns is based on the weight of the airplane. So I think, for example, probably the reason that the later model 210s were 8-ply tires were because they had a little higher gross weight.
Right. They did. Yeah. It went from 3,400 to 38 and then eventually to 4.
Which is why it's not a good idea to go down a ply
right.
rating because the tire is not good for the weight. Well, it's probably good for the weight if you don't make hard landings. These tires have to survive. There's actually an FAA defined hard landing thing, a certain number of G's that the landing gear is required to
withstand.
and it's a whole lot harder landing than hopefully any of us ever make.
Well, I test that out on occasion just to be sure my airplane's okay.
Excellent. Yeah, my understanding is it's a lot to do with the deflection of the tire under the weight that it's expected to be under. So like 172 up to a 182 gets that bump and ply, normally speaking.
Yeah.
And oleo struts also, they have the same thing where the strut inflation is such that a maximal hard landing as defined by the FAA will not bottom out the strut.
Fingers crossed.
Yeah, right.
No, hopefully we never actually make any of those.
Yeah.
It is a flying club, right, John? You never know what you're going to get.
That's right.
Yeah.
It is. In any club of any size, you quickly get to discover the mystifying behaviors of others.
Right. That's why I like being a sole owner, because I only have myself to blame when I find a problem. Yeah.
Very wise, cool. I think.
That was a good question, John.
Yeah. I'm sure a lot of people had that question. Yeah. Thanks very much. Good luck with the club. That's an interesting position. And call us back because I'm sure you're going to see more interesting things in your tenure.
Well, don't call us about every one of them.
Yeah.
I have no doubt. Yeah, next time I'll I'll come up with something a little more complex.
Okay.
Oh, this is good.
No, this is
good.
fine.
Yeah.
No,
Cherokee fuel tanks, maybe.
Yeah.
Yeah. Oh, yeah. There you go.
Thanks for calling.
All right. Thanks
you.
a lot. So our next question is from Doug, who wants to treat his client's airplane nicely. So go ahead, Doug. What you got for us?
Yeah, thank you. So I provide multi-engine instruction, primarily recurrent training in Aerostar aircraft. And recently I've had a number of students ask me to omit the one engine inoperative training.
Isn't that the point of the training?
I would say there's not a close second place, right?
Okay.
Right.
And these Aerostars, they use the IO 540. There's different variants that are involved. Most of them are either the U2As or the AA1A5s and the S1A5s. Those engines have varying types of cases. There's what we call the light cases and the medium cases and the heavy cases. And there's been a lot of chatter in the Aerostar community lately that the light and medium cases are more prone to cracking when subjected to the one engine inoperative training. So we don't have access to a viable simulator. And as you can well imagine, the pilots that I deal with that do recurrent training once a year or even every other year, by the time they get to me, they've lost a great deal of their proficiency with the one engine drill. And so I'm very reluctant to omit that training. We do our best to, manage the engines as carefully as possible, to not, subject them to undue stress. But my question is this: how much abuse and damage is there really when we go from 42 inches to 10 inches? And we do it repeatedly throughout a flight. Is there a real risk of engine damage or undue abuse?
Have you seen Bob Hoover's video in his Shrike Commander?
Worse.
We all have.
Yeah. And those are big Lycoming engines.
Yeah.
Yeah.
I don't think I ever remember seeing his engines explode and come apart.
Yeah.
And he did that routine all the time.
But he wasn't doing abrupt engine cuts in his routine. He was flying a lot on one engine, but that's
Yeah.
a different story.
But he was turning it on and
It's-
off.
He was starting and running at full power and then going from that to off.
But he might not have pulled it fast, I guess.
Well,
maybe.
I don't
First
know.
of all,
And-
I don't think the case is an issue at all.
Right.
What's an issue is rapidly cooling down a cylinder. And the problem with rapidly cooling down a cylinder is that the cylinder, as it cools down, contracts dimensionally, and the piston, which doesn't cool down nearly as fast because it doesn't have cooling fins and it doesn't have airflow going over it, and the only thing that's cooling the piston is oil being splashed on the back of it. The piston doesn't cool down nearly as fast after you cut the power, and so there's a risk of scuffing
Yeah.
of the cylinder walls and the piston skirts. Kind of the same sort of problem that you have with unpreheated cold starts, where in that case, it's kind of the inverse, where the piston heats up faster than the cylinder does. But that's really the main issue is piston cylinder clearance when you cut power rapidly.
So if we're managing temperatures as carefully as possible, And for example, if we're, starting at 350 degrees and we cut the engine and we're going, let's say that we're doing this, we're demonstrating a one engine failure in the traffic pattern, and we're at 25 inches and this cylinder head temps are 325 or 350, and we're pulling a throttle back. Is that enough of a potential temperature drop or differential between the cylinder and the piston to cause scuffing? Or does it have to be more extreme than that?
Well, I mean, all I can say is I would recommend pulling the throttle back as slowly as you can. And I it's a trade-off between training value and being kind to the hardware. And I understand that the trade-off there. I'm a big proponent of doing that sort of thing in simulators. But if you have to do it in the airplane, I would try to pull the throttles back as slowly as possible, consistent with your training mission.
So you lose the shock factor, but you preserve the engine.
The
Right.
shock factor of the engine quitting.
Yeah.
Yeah. When I got my multi,
The shock factor on the pilot.
No, I meant
Yeah,
the shock.
that's
Yeah.
suddenly-
Who suddenly lost
Right.
his engine. Yeah.
when I got my multi rating, and I know this was in 1977, and it was in an Aztec, not an Aerostar, but it's the same basic engine. Yeah, we're cruising around at 75% power, and the instructor reached down and turns off the fuel. And I don't know how many times we did that. And flight school airplanes, Senecas and Seminoles, they do that stuff all day, every day. And I just don't see rampant cylinder failures, and I'm not saying it doesn't exist, but I think we really
I don't
overplay
think
the danger.
I don't think it's a question of failures. I don't think there's anything catastrophic that's going to go on.
What happens with scuffing? What's the process that takes place after scuffing has happened?
It's just a wear process. It's
okay.
It's that you're getting metal to metal contact where you really don't want to have metal to metal contact.
It's premature wear.
Yeah.
If the cylinder is smaller than the piston, or the piston is larger than the cylinder, it squeezes all the oil out, and
right.
And you can see it when you disassemble. When you pull the cylinder off, you can see what mechanics typically call comet tracks on the piston skirt. And if you look more carefully at the barrel, you'll see vertical scoring on the barrel.
So you would get lower
But
compressions.
it's
in the
not
extreme?
something.
Or
There's
oil
nothing
in the cylinder?
nothing really extreme about it.
Okay.
It just will
It's
cause the
accelerated
cylinder
wear.
to wear out faster than it would otherwise.
So if you
And
only
it's-
do it once a year, I mean,
And
is
it's
it-
only on the skirt. It's all below the piston rings. And you've got an aluminum piston typically with a steel cylinder wall.
so you wouldn't even see it on the borescope because it's below the rings.
I don't know that
You
would
might
recognize
see
it.
some vertical scoring on the
on the
cylinder
walls.
Yeah.
walls, which we see a lot anyway.
Yeah, but
Okay.
it's not gonna prematurely. I don't.
But there's
I
no
don't know that you would
danger
pull us-
involved.
Yeah,
And
there's no
nothing
danger,
catastrophic that's going to happen.
and you're not going to have anything that tells you should pull the cylinder prematurely. I mean, it's not that kind of wear. I mean, you could go to TBO and beyond and have this. I may have it on my shoot. I'll bet you that my pistons are, if this is real, my pistons have to look horrible. But I'm not going
Why?
to look at them.
Because you yank your power.
Well, as I often say, my airplane's a bit of a flying experiment, but I will move the throttle as I need to fit in the traffic, and I don't like to go slow 10 miles away from the airport. So I come up on the airport at an appropriate speed. At least I think so.
Yeah.
And I've just never had any problems. I bore scope regularly.
I mean, now that I think about it, I will fairly regularly run an ox tank dry. Intentionally when I'm on a really fuel critical mission, because there's nothing less useful than a small unknown amount of fuel in a tank.
Right.
And that causes normally I catch it very, very quickly and restore power so that it doesn't really have time to cool down very much. But we all have thermal episodes.
Let's call them. I like that. I just think if it were shock cooling, shock heating, if you accept one, you have to accept the other.
That's the other thing I hate to see is people who, on takeoff just jam the throttle forward suddenly rather than pushing it forwards nice and smoothly.
So, but I think if it were really a problem, we'd have cylinders, blowing out through cowlings left and right, and we don't.
No, it's definitely a non-catastrophic kind of thing. It's not something that we worry about from a safety standpoint. It's only from a cylinder longevity standpoint.
Yeah. Well, that's good to hear. I was hoping the answer would be along those lines, because I really believe the training value is very important. It's very critical. And I would hate to back off that over fear of engine damage. In the Aerostar community,
you guys need to get a Redbird simulator or something.
Yeah.
We're talking about getting a simulator, but nothing really replaces the actual event. In our community, and I'm 63 years old, and I'm kind of part of the youth brigade in the Aerostar pilot community. So our responses are getting a little bit slower, and it's important training. It really is. So that's good news.
When I did my multi-engine check ride, that really mean check ride pilot, I was ready, man. As soon as I got about 200 or 300 feet, I just knew an engine was going to quit. No, nothing happened. We flew around, did all kinds of stuff for like 20 minutes. And he was just waiting for this, the 17-year-old kid to relax. And that's exactly what I did. And somewhere we were at like 5,000 feet and the engine quit. And I was totally surprised. Just engines never quit up here. They quit right after takeoff. That's where we trained. Well, not right after takeoff because it's a piston, but at low altitude and high power and near VMC or at lower speeds. And I was all ready for that. And that is not what he did. It just totally threw me out of sorts.
That's good.
Yeah. It's exactly why he did it. So
that's what happens.
Get the shock factor.
That's why we do it.
Yeah. You're all vicious.
Okay. Well, I appreciate that.
It's not nearly as important to secure the inoperative engine quickly as it is to do it accurately.
Yeah, that's true.
Absolutely.
The correct engine.
That is absolutely right.
Yeah.
Couldn't agree more.
Yeah.
Mm-hmm.
Good.
Well, good question, Doug. Yeah.
I really appreciate that.
Tell them not to worry about it.
Keep torturing those airplanes.
That's right. And the students.
I'm going to tell them that you told them not to worry about it. I think I'll do better with that.
Tell them Mike said that, not me.
Use Mike's name in vain.
Just don't tell them not to worry about it. Just tell them it's non-catastrophic.
There you
go. Got it. Okay. Thanks.
All right.
Thanks so much for that, guys.
Thanks, Doug.
Okay, Doug.
All right.
Good to see you.
Bye.
Our next question's from Jason, who is deep in electrons. Go ahead, Jason.
Run.
You thought I was going to say something else, didn't you?
Yeah. Electrical problems have definitely been an issue for us lately. So we own a 1960 Piper Comanche 250 version. We do have an engine monitor before you ask that. And we've got our
you're a listener then, aren't you?
What's that?
You're a listener then.
Yeah.
Yes.
Yeah.
For quite a while. Actually, it's kind of weird listening to you guys at normal speed Usually I listen at 2x. So everything sounds a little slower.
I love it. Okay.
Anyway, but Comanche is parked in Las Vegas, and we've had some interesting voltage readings on our EDM over the past year or so. As we've taken off, climb, cruise, all that stuff, over time, the bus voltage as it shows on the EDM will come down into the 12s, still above battery voltage, which normally when we started up shows about 12.2 to 12.3. And the ammeter still shows that that the alternator is functioning with the needle being just to the right side of 0 after the battery gets charged. But it does tend to come down over time. After landing and taxiing back in, starting to shut stuff off, that voltage will climb back up, but then rest somewhere in the high 13s, about 13.8. And then since I've brought this up and asked this question and waited to get on the show and waited for a time that would work out, we've had an interesting development where the wife and I on Super Bowl Sunday went to Kingman for brunch. Great place to go to, by the way. And on the way back, right after takeoff, brought the landing gear up, and the gear came up normally, and I noticed the low voltage alarm on the EDM, so it started flashing the voltage at me. Got all the way down to 10.8, and the ammeter was showing a slight discharge, something around 5 amps or so, just before the first dot. So load shedded a few non-essential items, turned right back to the field. Gear came down normally. Everything seemed to be working fine. There was no degradation in any of the avionics or anything like that. And battery voltage or bus voltage came back up to about 11.2. Landed, taxied in, shut down. We left the airplane there, and over the week, as I talked to the mechanic over the phone, they started it back up and said the bus voltage is right at 14. So a master switch cycle seemed to make the issue go away. I got a ride to the airport about a week later, picked the airplane up, flew it back to Las Vegas with the gear down, and then waited until I was over the home field to do some testing. Tried turning everything on, so aux fuel pumps, pitot heat, all the lights, and orbiting over the field brought the landing gear up. And the gear the voltage went all the way down to about 12.5 in doing so. Didn't show a battery discharge, and it never went below that. Once the gear came up and showed the green light, the voltage recovered to about 13.2 or so, but that's about where it stood. So, and since then, another partner has flown the airplane, and he had basically the same thing happen to me the first time, where it seemed like the alternator dropped offline. He actually flew it around for, I'm surprised he did this, about 20 to 30 minutes, he said, after it showed discharge and the bus voltage came down, and flew around like that just on the battery, and came back, landing, gear came down normally, and he brought it in and shut down. So that's where we're at right now. And we're trying to determine if this is a regulator issue or an alternator issue or something in between.
Something.
Well, it sounds like it's almost certainly a regulator issue, and it sounds like it's an issue where the regulator works when it's cold and doesn't work right when it's hot. That's sort of was the vibe I was getting. Well, this is certainly an unacceptable situation, and I wouldn't continue to fly the airplane in this condition. I would get this thing fixed, but it sure sounds like a regulator to me, doesn't it? What do you think, Paul?
Yeah, that's where I'm going. So, do you know what kind of alternator you have?
I don't know the brand name. I know it's a 50 amp.
Is it like an Inter-Av? Does that sound familiar?
I'm not sure.
Okay. It's not a generator.
No.
Okay. I had a 58 250 Comanche, serial number 317. It was a beauty.
What year Comanche is this?
1960.
Yeah. So I think that originally came with the generator. I'm pretty sure.
Yeah.
So it'd be interesting to know what alternator it has and what regulator it has. But so always keep in mind, just I tend to simplify the electrical stuff, and I've run this by Colleen, the electrical instructor at the A&P school, and she hasn't dissed me for it yet. So voltage tells you if your charging system is working. Amps tells you how hard it's working, and you really don't care how hard it's working. You just care that it's working. So if you've got 12.5 or less volts on the bus, your charging system is not working. And it's just that simple. If it's got 13.2, it's working, but not great. If it has 13.8 or 14, that's where it should be.
Should be, for sure.
Yeah. The airplane is old.
And you're saying that's where it is when it's cold.
Yeah.
Yes.
Yeah, it starts out at 13.8.
This
14.
seems like it's almost got to be a heat-related regulator problem.
It's old, though, so you have to add that in because last week we had a 182 guy that spoke Southern like me, and he had circuit breakers. They had high resistance, and when they get hot, they'll have even higher resistance. So it could be something like that in the circuit. Probably not, but if you still have all the original circuit breakers, I would, just in my troubleshooting, I would start by checking the resistance of the components in the alternator regulator power supply and in the field lines. It's real simple checks to do before you buy parts. Get out the ohm meter.
Can I weigh in? So I had a problem like this in my Cardinal, which is retractable, that the JPI engine monitor was showing lower bus voltage than I had another voltmeter in the airplane that was showing, it was a difference. And the JPI would drop offline because the voltage would drop when I ran the gear motor. The gear motor takes a huge amount of inrush current. So you get a big current surge going through your electrical system initially when the motor starts, and then actually when it stops too. I think it's so it was putting the JPI offline, and actually sometimes my radios too, because they don't like low voltage. It turned out it wasn't the alternator. It's not that the alternator can't keep up or the regulator can't tell the alternator to keep up. It was in the firewall back, not firewall forward. It was under the panel where the current came from the alternator to the bus. It went through an ammeter, and the ammeter, a shunt for the ammeter to pick off the current and to show what your charging is.
Yeah.
And there was a loose connection back there that was very hot. And it created a huge amount of voltage drop because there was high resistance due to the loose connection. And the system was just losing voltage right there behind the panel. And I just happened to find it one day. We tried all kinds of crazy stuff thinking it was the alternator.
That sounds a little strange because Cessnas usually have battery ammeters where the shunt is between the battery and the bus, whereas Pipers usually have load meters
on the alternator. Yeah,
where it's between the alternator and the bus.
So it might have been pulling from the battery to the alternator when the motor was operated. I don't. But it was the shunt that was the problem.
Yeah.
The point is, it could have been the shunt. It could have been where the power connects to the bus. That connection could have corrosion. It could be at the at any of the circuit breakers. It could be at the gear motor switch. I don't know. But there's so many places in these old aircraft where there's corrosion, and that creates a voltage drop when you run the motor.
So,
Colleen, in the scenario you just described with the Cardinal, were you having a problem where the system was okay when it was cold and not when it was hot? Because that sounds...
It was a problem when I ran the gear motor. So that was when I was in the air. I don't remember it happening on jacks.
Well, the vibration will put a lot of that in there. So things that are good in the hangar, we get this with landing gear systems quite often. It works great in the shop, and then you start the engine, and all kinds of things don't work right. Switches, circuit breakers, which are just glorified switches, all those things that have oxidation. And not to be insulting or anything, but your airplane's an antique. And all those switches and things are oxidized and all that. So while I think it's probably regulator related, don't skip the troubleshooting of checking all, and that's a big order, all of the switches that turn on and off the alternator, circuit breakers, all those things. Some of those breakers haven't been tripped since they were new in 1960.
Yeah.
And boy, there's all kinds of corrosion in there. This is one of my favorite.
But if any of them were causing problems, they would feel hot.
Yeah.
Right.
Yeah, so they would feel hot.
That could be a troubleshooting strategy. Is
run your hand along.
To wait for the thing. Get the thing to where the bus voltage is dropped way down low, and then put your finger on a bunch of stuff and try to figure out if anything is hot.
Or better yet, consider swapping out your circuit breakers for pullable circuit breakers and doing a modern upgrade to your plane. They're not that expensive.
And when they get hot, the wires at the terminal ends will also often discolor. So you can look for that as well. That happens.
It's interesting to take a little tour behind your panel. You'll see all kinds of crispy critters back there.
I don't know. Interesting is not the word I would use.
Yeah.
It's
that brought up an interesting point,
the panel.
Colleen.
We did rewire the panel about a year ago
with new breakers.
I don't know I don't think the breakers are new.
Yeah, when they rewire the panel, they often don't rewire the bus bar and the charging system. They do all the avionics stuff.
Yeah.
So just something to point to. Yeah.
Okay.
So Colleen brought up an interesting point about installing pullable breakers. I have always thought that non-pullable breakers should never have been certified. The idea of having a circuit breaker in an airplane where you can't turn it off has always really spooked me. So I'm a big fan of replacing any non-pullable breaker with a pullable one.
You can do a couple a year. You don't have to do them all at once.
You don't have to do them all at once.
Yeah.
If the bus bar will let you do that. Sometimes the bus bar, the new breakers aren't the same depth or shape, but
breakers are simple, but it's the form factor. It's like a light bulb. You have to have the right base, and sometimes it's hard to find the appropriate breaker to fit your bus bar. Cessna
has this wonderful document, and we show it in the Cessna classes that I do for CPA, and it's obvious that engineers wrote this document, but it talks about if you have this wandering amp-meter, or it's like a windshield wiper, the amp-meter does this. That you should replace the alternator, replace the regulator, and it lists all the parts that you should replace.
Starting with the most expensive, right? And
it
working
starts at
down.
the most expensive. And then there's a note, the very last thing at the bottom, and it says, if you tried replacing all these parts, you might want to try replacing the switch and it talks about high resistance. So I'm like,
yeah.
So in class, I tell everybody just to read it upside down.
Yeah,
exactly. And you do it in that order, and you're way better off.
Yeah.
But find somebody that knows how to use an ohm meter.
Yeah, and it's hard.
Okay.
You have to trace wires. The wires
access.
But this one's going to be a little tricky because it sounds like it's heat related. It sounds like it works okay when it's cold.
Could be. Yeah.
Yeah.
So I'm still leaning towards the regulator.
Okay. It does seem to change. I mean, with that heat, you saying that's heat, as we turn things on, it seems to affect the voltage. So
that would be regulator. If more power, it could be where the regulator is sensing. Still, in any troubleshooting on alternator systems, I always start with an ohm meter or a voltmeter. And
heck, for all we know, this system might use one of the old vibrating contact regulators. I don't know what kind of regulator it's got.
Yeah, if it has an old Delco Remy,
which is a blue case, right?
yeah, a blue case looks like something out of a 57
I've
Chevy.
got 3 in my hangar you can have.
No.
Thrown away
If it has one of those, take it out and throw it away.
Yeah, get a Zeftronics or a solid state.
Yeah, get something solid
state. A regulator is not that hard to swap. It's bolted to the firewall or somewhere, with 2 screws, and then it's got 4 or 5 wires. It's not that hard to replace. Yeah. You could actually, swap it out with another aircraft and just test fly and see if that solves the problem.
Yeah.
I feel like our regulators are actually, so they're on the people side of the firewall, just in front of the the footwell, just in front of the rudder pedals on the co-pilot side. Yeah, I've seen it. There are these little silver guys. They're kind of difficult to see, bundled up in there.
Boy, looks like a box, like 4 inches by 2 inches box.
It's easy to find
with like 5 wires to it.
Yeah.
It's got terminals that you just screw the wires in. It should be pretty easy to remove and replace. Just put the wires in the same place, or unless you're upgrading, then there might be a little bit of figuring out which wires.
I can't imagine why a regulator would be on the inside the cockpit. That doesn't make a lot of sense to me.
The easiest way to find it is go to the alternator, find the field terminal, and follow that wire, because the first place it goes is to the regulator.
It's a small wire.
It should be
the only place it goes. Is
only place. Yeah.
Fair enough.
When you figure it out, let us know.
Yeah, but maybe start with the regulator. That's easier than tracing, with a voltmeter under your panel. And feel for a hot breaker. That might be a dead giveaway as the voltage is dropping. That might be easy. Don't burn yourself, though.
Yeah, there's no AC under there, so you're not going to get zapped.
But don't reach under the panel when you're flying or use a screwdriver. I've done that, and I've blown. I was like,
well, don't use a screwdriver. It's okay to it's okay to reach under there, but don't use a screwdriver. I did that once in flight, and I blew a breaker. Yeah, don't do that.
Yeah, no tools.
Got it.
Oh, I remember. I remember once when I did that years ago and wound up incinerating a lighting rheostat. It just like
that's expensive. Yeah,
went incandescent and blew up.
It's a terrible thing when, while being a pilot, you suddenly switch to mechanic mode.
Yes.
That's very dangerous.
You can get in lots of trouble.
Yeah, I've shut engines off. I've done all kinds of things. Like, sorry guys.
Yeah. All right. Well,
fair enough.
Jason, we're laughing, but you're not laughing so much. I hope that we get something useful.
I'm on the West Coast, so it's a little earlier for me.
I'm on the West Coast. I'm with you. So, but anyway,
Paul's the only one that's back east.
Yeah,
I'm on the right coast.
He's way back east now.
Yeah,
but we would like feedback. Let us know how it goes. Hopefully, the regulator might do the trick, and you can find it easy.
Yeah. Sounds good.
Okay.
All
right. Good luck. Thank you.
All right. Thank you.
All right. So we got a good letter from Steve, and he's asking a question that I don't think we've ever had on the show before. He's got an 0470R in his 182 and recently did an overhaul with Western Skyways. And when he was sitting down to spec out the new engine, they said, do you want a congealing or a non-congealing oil cooler? And he thought, well, congealing is a nasty sounding term, especially when it's associated with oil. So he elected to go for non-congealing.
Oh, good call.
Sound logic. But he lives in Arizona and he flies there in the summer. And what he's found is that he thinks the engine runs a little hotter than the old engine. And he's also found that his long climbs and hot days will increase oil temperature above what it was. So now he's wondering, did I make a mistake?
Interesting.
Well, first of all, his new engine probably has superior cylinders on it. If it came from Western Skyways, and the superior cylinders,
Millennium cylinders,
tend to run a little hotter.
Interesting.
But it's an interesting question that I hadn't really thought about before. But the congealing oil cooler is pretty much dimensionally the same as a non-congealing oil cooler. And since the non-congealing oil cooler, the difference is that the non-congealing oil cooler has a fairly large line that loops through the cooler that passes warm oil through the cooler at all times.
It's a
I think
preheater.
that, yeah, but I think that probably means that the non-congealing cooler probably has a little less cooling capacity because
I think it does. It has less surface area. I'd never really thought about it.
I never thought about it either, but the non-congealing cooler is a good thing to have if you're flying in cold places. I used to have a Cessna 182s, my first airplane that I bought when I was 25 years old, and I used to fly it up to go skiing all the time, and a couple of times on departure, the oil cooler would be all frozen up, and you take off, and you'd see the oil temperature going through the roof.
Yeah, right.
And then all of a sudden, boom, it would come down when finally enough engine heat propagated to the oil cooler to unfreeze the oil cooler. But the non-congealing cooler is designed not to do that.
You mean the oil temperature or oil pressure?
Oil temperature.
You did mean temperature.
Yeah.
Okay, so the cooler's not doing its job because the oil's not
because it's frozen up.
Okay,
it's congealed.
Okay.
Yeah, and of course, I was using Airshell W100 oil. I wasn't even using multi-grade oil.
Okay.
Because I'm based in California. Mm-hmm. But it's kind of a little spectacular what happens when you take off with a congealed cooler.
Yeah.
And of course, the Cessna 182 and all the Sandcast Continental engines have the cooler up front, where it can get really cold. I think the Permold engines that have coolers in the back, I think Permold engines, they're all non-congealing coolers. I don't think you can get the two types of coolers for those engines. So I think this is only for the Sandcast Continentals.
So
but I think logically logically the non-congealing cooler, which is a better cooler if you fly in cold weather, probably does have less cooling capacity in hot weather, just because there's a big, fairly large diameter loop of tubing that goes through the cooler to make it non-congealing, and that would necessarily subtract from the area of the.
Yeah, I wouldn't have thought it would have been that much. I mean, we almost never see non-congealing oil coolers. So I hadn't really thought about that, but as soon as we started talking about it, it's like, well, it was an odd question to start with, and I'm thinking, well, no, that can't be related. But then it's like, well, yeah, it could be. I still think it's maybe not the total cause.
It's the Millennium cylinders, right? That's probably.
I think that could. Well, of course, the Millennium cylinders will. Yeah, I think it's more the cylinders than the oil, but nevertheless, the non-congealing, it's a pretty cool thing. You circulate all this warm oil all the time to preheat. And the first time I really thought about the impact of it, because I'd never heard of anybody having a problem. This is the first time I've heard this story from Mike, is watching, what was the TV show up in Alaska, and they have the C-46 and is it Air Alaska Wings? Oh, can't believe I can't remember the name of it.
Flying Wild Alaska?
Yeah. So they take off in the C-46, and somebody on the ground had forgotten to put the blanket around the oil cooler on the right engine. And they take off and they're in cruise and their oil temperature is going through the roof. And they actually had to, I don't remember if they declared an emergency. I think they did, and turned around and went back to base because the oil cooler was completely congealed. Yeah, it was just frozen up.
Mm-hmm.
That was very interesting.
So I guess to answer the question, did he make a mistake?
No,
probably not. No,
It's
I mean
probably
maybe, but probably not.
A better choice, but it is causing higher temperatures possibly.
And he just has to probably live with it. It's a 182; it can handle it.
Yeah.
Yeah. Well, I mean, it's like a question we had earlier about, you don't see cylinders coming off for engine shutdowns, in multis. It's like, I mean, airplanes move around a lot, right? And they're bought and sold, and it's not like it's not part of the purchase process. People aren't saying, "Oh, do you have a non-congealing or a congealing?" Because that really matters to me here in
Nobody
Florida.
ever asks. Yeah.
No.
Yeah.
But if you think about it, the oil flowing through the non-congealing loop is basically not really being cooled.
Not cooling. Yeah.
Not much. Yeah.
Yeah. But how much of a difference does it make? It's hard to say.
I don't know. I don't know that enough people have experimented with that that'd be kind of hard to test.
I'm going to cut my oil cooler open to see what I've got.
Go for it.
I'm curious.
You can look at it from the front. So the way you find out, when you look at the front of the oil cooler, it has the fins, and in between the fins are the tubing, I guess you would call it.
Yeah.
And across the middle, let's see.
A non-finned part?
It's a non-fin part. It's usually maybe a half-inch wide.
Oh.
It's real easy to see on the front of a Continental because the oil cooler is just right there. There's a diagonal structural brace that's welded on the cooler, but this is a lateral. It goes left to right.
Okay.
And so you'll see a thicker. It's right in the middle. I mean, because that's the whole point, is to warm up the entire oil cooler. So you can.
Hey, Colleen, you and I ought to just go fly to Van Nuys someday and go visit Pacific Oil Cooler. And
I would love to.
That would be great.
Yeah. Well, we're out of questions, so let's wrap this episode up. Thanks for all the fan mail, and thanks for your steady stream of questions. That's what makes this podcast special. Keep them coming to our email at podcasts@aopa.org.
See you, everybody.
Bye-bye, everybody.